How to navigate a 3D scene and the difference between local and global coordinate system. Hello guys, in this video I'm going to explain the very basics for 3D modeling applications, how they behave and how you navigate the 3D scene. This is not software specific, maybe some of them of the available settings, but the base is specific to SelfCAD, what I'm using now for this. But the basic concept applies to any 3D modeling software you'll go. So let's start it, first of all, the concept. So if I'm going to go, for example, drawing something, if you're used to 2D drawing, I have an X and Y axis normally. If you go to 2D, usually you would have the X would be the horizontal axis and the Y would be the vertical axis, and you can draw straight lines, okay, in one direction. Obviously mine is not straight, and this, not to go into the settings, you have options to make it straight, but nevertheless you can draw kind of around or any other way you want to draw around, and that's basically freehand drawing kind of, which actually use this freehand drawing tools. I'm not going into details from this tool specific how this works, that's not the point of this video, but the point here is that you can freely move on a 2D axis, on a 2D plane. That's called a plane basically. The thing that I'm drawing on is a plane. You can freely move around it. However, when it comes to 3D, that's not the case. In the real world, if you have something in your hand, you can move around freely in all three axes. I mean, completely in your entire environment. When it comes to a 3D space, we are limited to moving stuff freely on a 2D plane, like the example I showed you now, which is a 2D drawing within a 3D application. Similarly, I can take an object and move it around freely onto a 2D plane. That's freely. But if I want to move it up, I'm not going to be able to move it up like the same way you can freely move stuff in your physical object you're holding. You have to have some helpers, and these helpers are called gizmos. And for that, we go to a tool that's called Move. I mean, you don't have to go to the tool. You can enter a position. For example, here in the bottom, we have three axes, X and Y and Z. This is how it's demonstrated. You see it over here. You can click on it. You can actually flip the axis to be the Z up, and that's a different conversation how this topic goes. But there's some applications have it like this, some like this, and SelfCAD default would be Y up, but you can flip it. But nevertheless, you can either manually enter a direction position for any of these axes, or you can take something that's called gizmos. Once you open the Move tool, it gives you something gizmos, and the gizmos will give you something that you can freely move around. That's the center gizmo by default, and it will give you a fixed axis colored based on the axis. So you can move it in the X direction, which is usually colored red, and the blue direction, which is the Z, and then in the green, which is the Y. So you're kind of moving it in just one direction at a time. Even if we allow you to move it in multiple directions at once, it will be only on one plane, which in this case the primary plane is the floor, so you can freely move it onto the floor. Okay, you can choose to move it between directions, like in between two directions, by using one of these smaller gizmos, kind of move it in one direction or another. So this is first of all just the basics to understand how objects behave moving. So you are kind of restricted to moving in a 2D plane, and that's just the physics how it works, because technically we're working on a 2D screen, and the way we interact with objects and work, that's how it works. You may find in certain applications that have no other function, just rotating the scene, that you can have more free scrolling, rotating. That behaves a little bit different, less fixed to an axis, but it's very difficult to get them with exact, accurate precisions and so on. So when it comes to 3D modeling, regardless which application you are doing, you are usually limited to just one axis or two axes, but never freely move in three axes. Okay, so that's just how to understand that why you need to have sometimes helpers if you want to move something precision and so on. Now the other thing is, why do we need axes? And that's actually the case in the 2D plane as well. I mean, if I'm drawing something freely, kind of like moving this freely, I mean, am I limited really to X and Y or to X and Y and Z? The truth is no, you're not, but this is kind of a guide that we are giving how we're measuring it based on something. And that's how basically we go in the real world as well. If you measure a room, you would measure it based on some axes and something. You may decide to have, octagon room, you may assign to it more axes. You can decide how you want to do it. But ultimately, in order to get an accurate measurement, you must have some guides, something. And in 3D space, we use X, Y, Z. In 2D, we use just X and Y. But there is a big difference between 2D and 3D or physical objects. And the main difference is the way we measure. So if you think about a normal measurements, you measure from 0 to 1. So if I'm starting to measure from here to here, for example, my 0 space would be, I have a total length. So total length of this, I didn't touch entire space. The scene is actually 700, my screen. You can go to workspace settings and change the size. My size now, default size is 700. So if I measure whatever from end to end, this will be, for example, whatever it is, this will be 700, but yeah, if I touch the exact end, so I didn't. If you touch, for example, this object is 100, if I measure from here to here, this would be 100. And it starts from one end to another, meaning is the beginning is the 0 point and the end is the final point. That's not how it works in 3D. In 2D, you may find the same concept, depending on the applications. In 3D, that's not the case, and there's many reasons why this makes modeling very difficult. The most simplest reason is that 3D space is infinite. I mean, technically you can measure any shape and any size and anything, and starting from an end must have a place where to start from and to finish it, and it must be specific locked axes and so on. So the way 3D is working is that we measure from a center point, and that's usually the center is the pivot. And if you see I make everything 0, that will be 0. Now, because we have technically 0 would be the center in the middle of the scene, meaning is if the height is 700, all of these sides are 700, and the height is 700, so the middle would be kind of over here would be the center. But the thing here is that because this is the primary plane, and that's how we work, and actually SelfCAD limits you, restricts you from going outside. So if I'm going to move this down, kind of negative below 0, it will jump back up. Similarly, if you're going to move it outside, it will jump back in. We don't allow you to go outside, so you can keep control of your objects. If you need more space, you just make bigger the workspace. But nevertheless, if you look over here, I know the length of this is 700, and if you see the position is actually in the X is 300. Okay, so why is this only 300? Why is this not 700? Now, the truth is that if you divide 700 in half, you should have 350. So we need to understand two things. First of all, why is this not 700? But even if I use only half of it, measuring the center, it should be 350, not 300. So what's happening here is that we measure from the center of the scene over here, kind of like in the middle where these two big lines intersect, crossover, this cross section. You can actually change all of these also in the workspace settings to set how the grid would look like, how many, the workspace size, segment size, how big each segment is, how many segments you want to have, and you can change, many stuff. Again, not to go into this now, but you can change basically everything. Everything is changeable. But what happened here is that we measure the center from here, so it will be 350 in one direction, 350 in the other direction, and the same the front and back. But when it comes to the height, we measure this is the 0 point. And this is basically what we call the pivot point. So the pivot point from this scene, the entire workspace, entire thing you work on is the scene actually. That's what we call the scene. So the entire scene is measured from the pivot point from the scene would be the center point on the floor. If you go below the floor, it will be -0. Actually, SelfCAD doesn't allow you to do it, as I said before. But technically, if you go below, that will be -0, and anything above will be positive. So the max positive you can have is the size of your scene. In my case, that will be 700. But if you go to the other direction, because you measure from the center, you can have max 300. And max 300, in my case, of a scene is 700, and same with both sides. The scene size in SelfCAD is always rectangular. So the same size will be all over. Now, the same thing, that's kind of what we call the pivot from the scene. A similar concept applies to an object. So I know this object's size is 100 by 100, this cube. And if I measure something, I would measure from the center bottom. Same way we have the scene, I will measure the center bottom from the object. And that means that the object basically uses the same concept and the same measurement from the scene itself. And that's basically called global coordinate system, which is the measurement from the scene, and that's the global coordinate system, the measurement from the scene, the coordinate system from the scene, so to speak. And then the object follows the same logic, and it's basically using the pivot would be the center. And more importantly is that that's not necessarily positioning a pivot does not necessarily mean changing global local coordinates. What it means is that if I'm going to move it, use a gizmo, it will be aligned with the same thing. So we align it is basically, in this case, the X is this way, and the Z is the depth, and then the Y is the height. and regardless of the angle of the object. So where this makes a difference is, so if I'm selecting this object and we're going to move it, okay, so I can click here, actually center object. If I center it, see it's positioned in the center. So first of all, if you think about it, if I'm going to measure from the center over here, I'll be 350. But if I'm moving this all the way to the end, okay, the position would only be 300. Why is that? Because I measure from here. I don't really measure from the end. If I'm going to take a measurement and measure from this point over here till the center of the scene, oops, I didn't measure here. Okay, so from here to here, you'll see I'll be, okay, 354 because I'm kind of give it an angles more, but you get the point. It's basically from the end till here would be 300. So if I do something like this, this is 350, I mean, this would be 350, okay? So I didn't touch exactly. And this is why I do another thing, how you want to snap to this. You see, I didn't do this. When it comes to drawing, we have this option actually to snap to points, but that's a different topic when it comes to drawing. But now I don't really have anything snapping. If I click here, I can actually snap to it. This helps me draw straight, so that's why I can get it exactly 100 because I can snap. But on the grid, I can only snap in the middle of drawing. But nevertheless, if I do this way, I get the entire size. But if I use the measurement, the move tool, I only get 300 because it measures from the center. Okay, so far so good. Now if I'm going to move this up or move it down, anything, you can see these gizmos are aligned, regardless which way I'm using, even if I'm using one of these or the free one drawing, they're all aligned with the scene, and that's perfectly fine. So nothing happens if I move it up and down, the object does not deform, it stays in shape. What will happen if I rotate it though? So rotation again will work around the scene. I actually rotate always around something. So it's kind of like hinges, you rotate around something. So if you look over here, it's very easy to look. I always look at these guides. And if I want to know what I'm going to rotate around, so you can think about I'm rotating around this guide. So if I take this blue one, means I'm going to rotate it around and I'm moving it by 45 degrees, let's say. Okay, if you want to have actually exact precision more, you can change there's a setting over here for minimum step size, and that's the default. I guess it's 5. I don't remember if I said it, but that's the default. But nevertheless, if it's 5 means it will be in lock steps of 5, so it will be easier to position. If you make it, 0.01, it will be much more difficult to get exact precision, but it will give you more option to make it more accurate and smaller numbers. But you can play with these settings. But nevertheless, if I did this and I rotate it, and now if I turn on the move, you see the move is still aligned. It's not aligned with the object now. The object has changed. I did nothing, I just rotated it. But the move is still aligned with the scene, so where the green axis is still always up. And this is where it starts becoming problematic. If I'm going to move this up, actually moving over here, it's not going to be an issue because I moved the entire object. And if I move the entire object, technically it wouldn't make an issue. But the thing is, if I'm going to select a face, let's say just one part of the object, and now this is going to start becoming problematic. If I start drawing this, moving this, it starts deforming the object because I'm stretching it in a way that is not perpendicular to its current direction. So if I take, let's go back, undo. SelfCAD does a very good undo redo, so I can just undo everything. And now if I'm going to select this face again, and if I'm going to move it, I can keep on moving it and use it kind of as a scale, because I'm basically just stretching one face up and down, and there's no problem whatsoever. But once it's rotated, I'm moving it away, and this becomes problematic. So let's just rotate it again, and let's see how we're going to overcome this problem. So if I'm going to rotate it something like this, and now I'm going to select just one face, I'm going to go to the move tool. Okay, so there's two ways to do it. So the first thing here is that I can choose something called local transformations. And local transformation, this is basically, as the name suggests, it's local. And local means it's using this plane as the axis. So think about this plane is now the floor, the grid. And instead of using the grid as the main coordinate system, you think about this is now the workspace. And because this is the workspace, it has the freehand moving, I can move around freely, has all of these other gizmos, directions, including the Y direction. And now I can just move it in the Y direction without any problem because we're using local coordinate system. This is basically local transformation, means local coordinate system. Now this works very good when you're working with a single face because it's easy to use this because this is planar. It's called planar, meaning this is flat, it's a plane. Same way I can use the grid as a plane, I can use this face as a plane, face or polygon, whatever terminology you used. We'll discuss this in a different video. But for now, the main concept is that it's flat. Because it's flat, I can use this to give me the axes, the coordinates, and align the gizmos with this as a term of using local coordinate system. But this is not going to work if I have an entire object, and if you deselect the faces, you'll see the option local coordinate system disappears, because there's no way to get a local coordinate system from entire object, because this object has, it's not 2D. It must be 2D, like the grid. It must be flat. This is not flat. That's not 2D. So how do I overcome this problem? To show you a real practical use case, I want to show you actually another example. So I'm going to take a new cube, and this time, instead of drag and drop, just to show you, I can click on it, open it, I can customize it, and maybe I'll add the width, let's say, to 300 or something like that, and I'll finalize it. Now I'm going to take just one edge. I'm clicking on this edge, and I'm going to move it up. In this case, instead of using the gizmos, I'm going to type in 300. So I kind of gave it an axis like this. Okay. Now suppose that I want to add a railing here. Obviously, I'm not focusing on design now. It's not going to be perfect, but just the concept. So if I'm going to go add a railing, I'm going to add another cube. But in this case, I want it to be, the size would be, let's say, the width would be, let's say, just 20. Okay. Or even less, let's say just 10. And then the height would be, let's say, 300. Let's see which side, not this way. I guess I can make it like this, 10, something like this. And now let's move it. I can use the moving over here. Also, I'm going to position it. If you think I know this is 100, if you see over here, actually this is 300. The depth is only 10. Let's see, where am I now? Oh, I'm talking this object. I'm sorry, I'm looking at the wrong object. This object is 100. Okay, the size of this is 100. So if I make this 10 and I measure from the center of it, okay, and this 100, so meaning is I need to move it by 50, but minus 5. So I need to move it by 45. So I'm going to position it. And this is another thing that I didn't say before, that when we measure from the center, we must have one direction that is positive, one is negative. I said before that below the scene would be technically negative, even though we didn't allow it. But when I go over here, which one's positive and negative? And this actually, we use common sense. Actually, in Wikipedia, I saw an article that shows an image that is flipped a little bit. So it looks like there's not consistency throughout applications. But in SelfCAD, it's just common sense. The front would be plus, the back would be negative, and the left will be negative, and the right would be plus. And actually, SelfCAD is marking that, so it's easy to see. You can see a plus sign here, and the other side will be a negative sign. So if I want to move this over here to the front, I would need to add in the Z direction. I look over here. So I'm going to move it away by 45. Okay, and now if I move it to 45, this is perfectly aligned to this, as you can see, because I measure from the center of this, and so basically I need to kind of give it credit for 5, because we don't measure the entire thing, just the center, and then from the center here away, which is positive 45. If I move the other side, I'll make it negative 45, and it will position it the other side. That's basically it. Okay, maybe I should make it dentin a little bit, so not 45. I can make it maybe just 43, or even just 40, to make it something like this. Okay, now I'm going to rotate this. I need to rotate it around my Z direction. I need to rotate it by 90 degrees. Okay, and now actually you cannot no longer see it. Let's just move it up, just so we can see it to 100, something like that. Okay, now this object is positioned over here. My goal here is to be this aligned over here, and I'm going now later to scale it just to show you everything and move it. But how do I align this? Okay, let's finalize it. How do I align it with this? Now, I can start in rotating and start playing, kind of approximating to give it as an angle. Okay, I can try to see it, but this will not be perfect. I can use the tool, the measurement tool, and measure the angle from this, and then rotate this by the same angle playing. Yes, it's doable. You can do it. And in more architectural type of designs, you may need to use these type of tools to figure out angles. But simply positioning over here, do I really need to work that hard and figure it out? And the answer is no. It's actually quite simple. So first over here is that, as I said before, the concept that we can use something local coordinates and to detect its angle. So over here, there's a concept that is called a magnet. If I use the magnet, what the magnet will do is it will give me an icon over here. The center will be a magnet, and that will allow me to position it onto anything to snap to something. Okay. Now here the problem is that actually the axis from the magnet is no longer aligned to the center. So I need this center over here to snap. So I'm going to position the gizmo, which is the gizmo from this. I'm going to snap it over here. And now I'm going to use magnet to align it to this. So basically what I did is I said, okay, the gizmo, as I said before, we have two things we need to consider. We have the object that I'm going to position, and then the other thing, which could be the global scene or another object. In this case, the gizmo, because the way the object was positioned, the first time I started snapping it, it was kind of misaligned. So I had to tell it, okay, take the gizmo of the back end of this object, and now snap it to this one and position it over here, which is kind of allows me to position it, and this is kind of takes it automatically. It's not changing the global coordinate system. You can see the y-axis is still aligned, everything is still the same, but the angle took the angle automatically. The magnet tool will take the angle from the thing it intersects, and it will basically align it to it. So this allowed me to, instead of using my measurement tool and figure out exactly angles, this just took the angle automatically, it positioned it. Okay. Now, if I want to move this or scale it, how do I go about it? So here's the thing. I'm going to go first to scale and show if I'm going to scale this. Now, if I want to make this higher, this will obviously start deforming again, the same problem. And the same problem here is because the global coordinate system gives me the axis that is not perpendicular to this. Now, how do I do this? So what I'm going to do here is I'm going to use a manual transformation direction. So this is not really local or global coordinate system because, as I said before, local kind of needs to have the same condition as global, where it's flat, must be like a grid, a flat thing. So if I would select a face, let's say just this top face, I will get this option local transformations, and now I can easily move it. I can't really scale it because it's only one thing. If I select the back face as well, okay, the bottom of it, I'm not sure, or even just this one, two faces, now I can start scaling it in this direction, but I think the axis is no longer aligned though, so I'll have to take just the bottom of the face to align it. But the easiest way is to use actually move, because you don't need, let me just show you how I can actually do this. Let's isolate this for a second. I'm going to select this as well. So if I select the back and front, okay, now I can show this already, but oops, not to select this, I'm sorry, what I did as a mistake, I selected other and I lost my selection here. Okay, so I'm selecting this face and selecting this face. Okay, now I can make this visible but not selecting it, so my selection stays. I can use local coordinate system, and now I can use kind of one of these transformations. Actually, it did not help even. Okay, it did not help, it's still not aligned. Okay, so nevertheless, my mistake. So how do I solve this problem? So there's two ways to do it. The first thing is I can use the move tool, select just this face, and then use local transformations and kind of move it up like this. Okay, that can work. The other way is I'll go back to the scale tool and I'll choose, instead of local in this case, I will choose a manual transformation direction, and I will tell it, okay, go in this direction from here to here. This is the direction. If you notice, I actually didn't click on this object, I clicked on my other object. It doesn't really matter, it's just a direction. Once I give it a direction, this is now aligned to this. So I'm still relying on 2D axes, but I'm not saying go take it automatically from the object. All I'm saying is let me give you the direction, and that's basically what's happening here. I'm giving it the direction. Now here what you see is I'm moving it, scaling it symmetrically. Okay, there's an option for symmetry or not, and that's a different concept, different discussion, if you scale symmetrically or not. But nevertheless, here is what I was able to do and scale it in this direction using the scale. Now, what if I want to move it now again? So I go to the move tool. I don't want to always go to magnet, and magnet's not always going to work. You don't always have things that are 2D and so on. So how can I align it and move it in this direction? And this is where you go. I said before, if you don't really select faces, just entire object, it wouldn't really deform, but it will still not allow me to move it alongside this. So if I want to kind of move it, just position it here on this, I'll have a difficulty moving it. This is again where I have this option, manual transformation direction. Again, I'll give it a direction like this. This is my direction. And now you can see I can freely move it, slide it onto on top of this thing because I'm aligning it. So basically here, the concept here is that I can just go and select, let me just isolate this face over here, and I can actually move it and scale it this way and so on. So that's basically it. And the same concept applies to rotation when you want to rotate something around something. All of these have these things. So what I have over here is that I have a transformation. The last thing I want to show, the difference between setting a pivot. So I said before, if I measure this thing, it's measuring 300 in this axis. Let's see, not size, position is 0, 0 actually. Position is 0 because I'm measuring from the center of this. Now, if I go to the move tool and I would change the gizmo position, okay, position and direction is a different thing. I'm just changing the position to measure to go here. What happened is if I moved it here, all I did is I said, I don't want the pivot point to be in the center of the object. I want the pivot point to be at the end of the object. And at this point, is you can see that actually the position would be over here, and this direction will have here some size. I didn't position it exactly, so it's minus 151 because it's not exactly in the end of the object, but I can actually use over here exact positions. I can choose an exact position, and let's say it'll be the bottom. Now you see it's 150. It's exact because I said the back left. You see this is the back, okay, and this is the left over here. So the back left basically automatically positioned completely back left. So because I measure now, the object has not changed, only the pivot point has changed. I have now minus 150. Why is it minus 150 and minus 50? Because from here it's minus 50. Before it was 0 everything, but because I measure from here and the left side is negative and this side, back side, is negative, so basically because of that you have it negative 50 by negative 150. If I would change it to right, front right, I haven't changed any position, just the position of the gizmo, which is basically a pivot point. You see it turned to plus 150 plus 50. So that's basically the way these things are working. Now, so just to summarize quickly, what we have over here is that we have a scene that must have a system. We don't actually have a way to change the pivot point from the scene. The pivot point from the scene will always be the bottom center from X and Y, and from the height will be the bottom, but other sides will be the center. And what we can change is we can decide to use a face to give us a custom direction or manually give it a direction, and we can also change the pivot point from the object to measure from different sides. Now, changing pivot point from an object has other things than measuring. This is not the main function of the tool. The main function changing pivot point would be in rotation. If I want to rotate something, if I rotate this object, for example, around my y-axis, which is around this, so this will kind of rotate, it will rotate around its center, as understandable. It will rotate around the center normally. If I would choose to change the pivot point, either manual direction or position, let's just say position, and I position it over here, now this will rotate kind of a wide angle around that center. And this is mostly where this thing is used to changing the direction. I mean, position and direction, same idea. You can change to rotate it around something. For example, I wanted to rotate around this direction, and now I can kind of rotate it around this, changing the direction where it rotates. So that's basically it. If you have any other questions, please let me know. There's one more thing which is more advanced, and this is in general how it works in SelfCAD. So you have kind of the basic tools. It starts with create stuff, and then the basic transformations. Later on, you have the more advanced tools. In utilities, you also have some more tools that are related to positioning. So you have an align tool, you have a snap tool, and you have the measurement tool I touched before. Both of these tools are also very easy to align. So you can use align tool when align tool will basically be based on the global coordinate system, and snap tool will give you flexibility. It will add the option with magnet and more custom directions, but that's a different thing. You also have an option to position along something, along a path, for example, using the follow path tool, which is in the utilities actually, a follow path tool. Once you have a path and an object, but that's much more advanced and not doesn't fit in the topic for this video. And hope you enjoyed it. Let me know in the comments, and see you next time. Thank you. Bye.